There's a place on Earth where you'll be crushed by immense pressure before you even reach the bottom. No light, no way back, no sound, just immense pressure, like an entire bridge pressing down on you. Yet, life still moves beneath that dark layer, as if nature hides a secret from human eyes. And now, that secret is being eyed by the whole world. This giant scar is slowly devouring the Earth. In the Western Pacific, between Japan and the Philippines, lies a colossal rift, mostly unseen by the world. No snow-capped mountains, no scorching desert canyons, just a calm sea surface. Beneath that tranquil water, the Earth's crust bends, pulling down into the planet's deepest depression. That is the Mariana Trench. Its deepest point is the Challenger Deep, nearly 11 kilometers down. If Mount Everest were placed here, its peak would still be submerged more than a kilometer below the surface. This comparison emphasizes that while we look up for greatness, the extreme lies in the ocean's depths. The entire trench stretches over 1,500 kilometers, plunging straight down into the ocean's heart. The Mariana Trench resembles a long, winding scar on the planet's delicate skin. And like all scars, it is the result of a prolonged collision. Earth is not a static sphere. Its surface is divided into colossal tectonic plates, slowly drifting like ice flues on molten rock. Over the past 170 million years, the Pacific Plate, one of the largest, has moved westward. It is colder, heavier, and denser than surrounding plates. Here, it encounters the Mariana Plate. When the two plates collide, there is no explosion, no violent outburst, just a slow, persistent compulsion. The Pacific Plate, being heavier, cannot climb over. It is forced to dive underneath, into the molten mantle. That process is called subduction. It's a colossal geological machine operating for millions of years. As the oceanic plate is pulled down, it bends, breaks, creating a deep trench where the crust folds underneath. Each year, it moves only a few centimeters, but over millions of years, this slowness built an 11-kilometer abyss. The Mariana Trench is not an accidental hole. It's the mark of a constantly moving planet, sometimes devouring itself. The ocean floor we see as stable is pulled into Earth's interior, where pressure transforms matter. This makes the Mariana Trench not just the deepest, but the clearest manifestation of silent geological power. It reminds us that the ocean's peaceful surface is a veil covering a complex system operating beneath. Yet for centuries, all humans could do was gaze at the deep blue surface and speculate. No equipment was durable enough, no vessel capable of diving that deep. The Mariana Trench existed as a colossal question mark in the ocean. And for centuries, humans could only stand on the surface and guess. The death dive into the pitch-black abyss. In 1875, the British research vessel HMS Challenger performed a simple experiment to measure the seafloor's depth. The crew predicted it would only take minutes for the weight to hit the bottom, but it didn't stop. The rope kept slipping through their hands, coil after coil disappearing into the water. Minutes turned into hours, the sea remained silent. When they finally got a reading, it was nearly 5 miles. For the 19th century, that was an almost unbelievable depth. Many believed there was an error. The line was swayed by currents, equipment inaccurate. The idea sounded more like legend than science. In the decades that followed, other measurements continued to confirm the same. But measurements only gave humans a number.
They didn't give them an image. The Mariana Trench remained an invisible mystery, a dark expanse no one had ever seen. It wasn't until January 23, 1960, that humanity decided not just to measure, but to go straight down. The chosen vessel was no ordinary submarine. It was named Trieste. Its design looked almost fragile. Above was a gasoline float tank, and suspended below was a thick steel sphere, only 2 meters in diameter. The entire human life would be contained within that sphere. Inside were 2 pioneering explorers. They knew they were heading to a place where pressure could crush almost any man-made object. The dive began in silence. Trieste slowly descended, falling away from the sunlight. In the first few hundred meters, the water was still blue. In the next few thousand, color disappeared. After several hours, outside was only pitch black, and the temperature dropped to near freezing. All external sounds were swallowed by the colossal water column. Time passed so slowly it was barely perceptible. It took them nearly 5 hours to approach the bottom. Each meter deeper added tons of pressure. At over 9,000 meters, a loud noise echoed in the cockpit. A plexiglass observation window had cracked. In that environment, a small crack was no trivial matter. Catastrophe would strike instantly. No chance for repairs, no chance to surface in time. The 2 men in the sphere looked at each other. They were at the deepest point ever reached by humans. Above were nearly 11 kilometers of water. Below, hundreds more meters remained. They could turn back or continue. The decision was made. Continue. Trieste descended the final mile in absolute darkness. Upon hitting the bottom, sediment stirred up outside. After a few minutes, the dust settled, and in the faint light, they saw what many scientists believed was impossible. A living creature, resembling a flatfish, slowly glided across the seafloor. This moment remained iconic. In a place where pressure exceeded 1,000 atmospheres, where biological structures should collapse, life still existed. Trieste remained at the bottom for 20 minutes before ascending. Those 20 minutes changed ocean perception. The Mariana Trench was no longer a deadly void. It was an ecosystem. We had misunderstood its limits. Mariana monsters defy all biological limits. What makes the Mariana Trench different is not just depth, but pressure. On the surface, we live under about 1 atmosphere. At the bottom, it exceeds 1,100 atmospheres. That's over 1,100 times our daily pressure. Imagine an elephant's weight on your thumb. That force is on 1 square inch. Now, multiply that force across your entire body. Under such conditions, metal bends, plastic shatters, and biology, by logic, shouldn't exist. Calcium, main component of bones and shells, dissolves under deep-sea pressure and chemistry. Proteins, delicate structures for vital functions, can become denatured. Biochemical reactions operate differently. Here, biology no longer fully adheres to our familiar rules. But life doesn't disappear. It adapts. To understand that, one must descend layer by layer into the ocean. The twilight zone, where light is choked, from the surface down to 1,000 meters. Here, light is insufficient for photosynthesis, but it still exists as a faint signal. Creatures in this zone evolve in 2 distinct ways. Some develop enormous, sensitive eyes. Others choose a bolder strategy, creating their own light. Bioluminescence is the common language of darkness. It attracts prey, distracts predators, or finds mates. Light here isn't to illuminate, it's a signal. A typical example is the hatchetfish. Its body is thin as a razor blade, almost invisible from the side.
Tubular eyes point upwards, scanning for faint silhouettes of creatures above. Its belly has light-emitting organs. By adjusting light intensity, the hatchetfish blends into the pale blue background, becoming invisible from below. It's a form of camouflage using light. At greater depths, sunlight completely disappears. The midnight zone proned, where vision becomes useless. Below 1,000 to 3,000 meters, the ocean enters eternal night. No dawn, no dusk, no day-night cycle. In this environment, large eyes are no longer an advantage. Many species rely on other senses. They develop cells sensitive to vibrations and pressure. This allows them to detect the slightest movement in the water. Here, hunting relies on sensation. The gulper eel is a clear testament to evolution's extremes. Its body is long and slender. Its jaws expand enormously, almost disproportionately. Its stomach can expand to accommodate much larger prey.
In a food-scarce environment, opportunities are infrequent. Prey must be seized when encountered. Biology here isn't about beauty. It's about efficiency. Marine snow herons are the rain that nourishes darkness. If no light, where does the energy come from?
That journey can last for weeks. Over 95% of this material is consumed by midwater creatures. Only a thin layer remains to reach the bottom. But sometimes the ocean sends a larger gift.
When a whale weighing tens of tons sinks, it becomes an oasis on the seafloor.
Initially, scavengers gather, followed by crabs, worms, and smaller creatures. Finally, when the flesh is gone, specialized creatures like Osedax worms appear. They don't have mouths. Instead, they drill into bones, secrete enzymes, and absorb nutrients directly from the skeleton. A whale carcass can sustain its own ecosystem for decades. The Hadal Zone, biology's ultimate frontier. Below 6,000 meters is the Hadal Zone, named after the underworld in Greek mythology. Here, the Mariana snailfish was discovered at a record depth. Its body is soft, almost gelatinous, with a flexible cartilaginous skeleton. Instead of resisting pressure, it lets pressure pass through. Its body is empty, containing no easily crushed air pockets. It adapts by becoming soft. Xenophyophores, giant single-celled organisms, chose a different strategy. They are unusually large, surviving by absorbing organic matter from sediments. Where cellular structures should be destroyed, they thrive. Even deeper, some microorganisms don't rely on marine snow. They thrive on chemical reactions from minerals,
seeping through Earth's crust. When light is gone, the planet itself becomes the energy source.
The Mariana Trench is a natural laboratory where biology is tested under extreme conditions. Body structures, chemical reactions, and survival strategies are re-engineered. The greatest lesson is flexibility. When the sun disappears, life doesn't disappear with it. It just changes the rules of the game.
The silent invasion of metal ghosts. For half a century, the Mariana Trench returned to silence.
It remained deep and inaccessible, more like a scientific landmark than a regular destination. In 2012, an acclaimed filmmaker and explorer dove solo into the Challenger Deep. The journey was a symbol of courage. It reminded the world that this abyss was not a myth. It could be reached. Since 2019, a renowned deep-sea explorer made more dives than anyone. Equipment became more sophisticated, pressure resistance higher.
Dives were no longer just about reaching the bottom, but about measuring, recording, and sampling.
The real turning point occurred in 2000, when China's Fenduze submersible reached the bottom. The difference was not in the flag, but in the long-term strategy. Nations began deploying AUVs.
These devices operate for months, mapping topography, analyzing sediments, and collecting data at a lower cost.
The deep abyss transformed from an extraordinary place into a continuously monitored area.
The difference is clear. From individual dives, humanity moved to sustained presence through technology.
No longer just exploration or adventure. It's about building capability.
As data flows steadily and seafloor maps become more detailed, a new question emerges.
And data always leads to the next question. What valuable things are there?
Trillion-dollar treasures hidden in darkness. Beneath deep plains, amidst cold sediments, lie billions of potato-sized rocks. They are called polymetallic nodules. Outwardly unremarkable, inside are cobalt, nickel, and manganese.
These metals are becoming the foundation of a new energy era. EV batteries need nickel and cobalt.
Wind turbines and electrical storage systems depend on these elements. Smartphones, laptops, smart grids need them. As the world shifts from fossil fuels, demand for rare metals increases. This makes the deep seafloor a huge reserve.
If successfully exploited, these nodules could help a nation strengthen its supply chain and energy independence.
For many countries, this isn't just economic. It's a long-term strategic advantage. But the cost is greater. The proposed mining method is essentially vacuuming the seafloor, collecting nodules, and pumping them to the surface.
This process could disturb the delicate sediment layer that has been stable for thousands of years.
Widespread plumes of sediment could affect organisms. Many species are not yet fully described by science. The Mariana Trench is a natural laboratory for evolution under extreme conditions. Once altered, it cannot be restored.
The question is not just how much metal, but what are we willing to sacrifice for it?
But resources are not the only things at the bottom of the ocean. The world's lifeline lies beneath superpowers.
Beneath the deep waters are not just sediments and nodules. Hidden in darkness are thin cables.
Like garden hoses, yet carrying the pulse of the modern world. Over 99% of international internet traffic,
from messages, financial transactions, to satellite data, all transmitted through submarine cable systems.
They lie silently on the ocean floor, connecting continents. Most of the time, they are invisible.
But when a cable segment fails, an entire region can lose connection for hours, even days. The increasingly dense presence of autonomous underwater robots makes the picture more complex. Devices for mapping, resource surveying, or data collection can also precisely locate cable routes.
That doesn't imply negative actions, but it shows global digital infrastructure is not in the sky. It's at the bottom of the ocean, in a place few see. The deep sea is a potential vulnerability. Legally, the ocean beyond national exclusive economic zones is the common heritage of mankind.
However, rules governing deep-sea mining and operations are still being finalized.
Technology advances faster than regulations. Early investors, presence, and data collection can shape future standards. The Mariana Trench is a symbol of a new era, where science, economics, and digital infrastructure intersect. We have reached the bottom of the ocean, but reaching it doesn't mean understanding everything. And understanding everything doesn't mean being allowed to do anything. From a geological scar created by millions of years of subduction to a small steel sphere.
In 1960, daring to plunge where humans didn't belong, the Mariana Trench changed how we see our planet. There, biology doesn't follow familiar rules. Bodies soften to withstand pressure. Life learns to glow in darkness. Energy no longer depends on the sun. But as robots become a regular presence, and data is collected, and resources become a strategic calculation, the deep abyss is no longer just nature's laboratory. It's becoming a chessboard. If you had to choose, would you want this abyss exploited or preserved as a planet's secret? The Mariana Trench has changed how we view our planet.